All right, cool. So I hope you're enjoying the ARKit tutorial so far. There's going to be so much more awesome stuff that's coming up. So in the last few lessons, we saw how easy it was to create cubes and spheres and add materials to them and put them into our real world using ARKit. Now we could continue modding our cube or adding texture maps to it to try and make it look like a dice, but there's actually a much easier way. We can simply import a 3D graphic of a dice that someone else has already created in Blender. So Blender is this awesome open source piece of software that allows you to create really lifelike, really awesome 3D graphic assets. And unfortunately, I don't really have the artistic talent to be able to show you how to create these amazing things, but I can show you how we can easily incorporate and use 3D models that other people have created. And all you need to do is to go to a website called turbosquid.com, and they have a huge catalog of 3D models, including free ones as well as paid ones. So if you go to turbosquid.com and you search for dice, then you can see that a whole bunch of dice shows up, and you have to sort the results for the file format DAE. So the DAE format is something that will be compatible with our scenekit.scn file, and we can actually convert it into an SCN file. And because we're doing this as a tutorial, I'm just going to look for objects that are free, so 0 to 0 price range. And then let's have a look and see what we've got. So we've got 3 options, and I think this one to me looks the nicest and the most realistic. So you're going to have to sign up for a free account for TurboSquid in order to download anything. But once you've done that, then it's as easy as hitting download. And it'll show you a whole bunch of different files that you can download, and they're all zipped. So the one that you want and the one that is going to work with our project is Dice Colada. So the Dice Colada is the one that has the file format DAE, and this is the one that you're going to want to download and incorporate into your file. So once you've unzipped that dicecolada.zip file, then you'll see that it includes a whole bunch of files. And the main thing that you're interested in is this dicecolada.dae file. That's the main model of the dice. The other things are essentially materials and textures. The one that we're going to be using for our project is the new redbase_color.png. So all we need to do is select the dicecolada.dae and also select the new redbasecolor.png, and we're going to drag both of those into our art.scn assets folder. And now we can have a look at our dice. So the first thing is that when you open it, you might not see anything. And this is pretty worrying if this is the first time you are creating a new ARKit project. But if you open the document inspector, you can see you've got this dice object. And if you change the camera to the front camera, then you can see that you've got a dice. Now the dice isn't particularly visible because its material is this dull white. And what we want is we want to change it to that material that we incorporated, which is the new red base color. And all you have to do is, do you remember previously we were setting the diffuse on our object that we created? Well, you can also set it inside the interface builder for these scene files and DAE 3D models. So all you have to do is click on the drop down list, and instead of this ugly gray color, we can choose our own texture, which is going to be the new red base color. And now you can see that our object looks a lot more like dice. It's actually got faces and numbers, and we're going to render this in augmented reality. So there's a couple of things I want to draw your attention to. One thing is that inside the node inspector, if you have the dice selected, you can see what is the size of the bounding box, and this it's basically the cube that will contain this dice object. And you can see at the moment its default width and height is about 1 centimeter by 1 centimeter by 1 centimeter. Now you can scale it up or down just by dragging this toggle or just double clicking and typing it in. Now a good reference point is that you remember how big the ship was when we rendered it, right? And if you select on the ship mesh node, you can actually see how big the bounding box of this ship is. And it's absolutely huge. It's 48 meters by 17 by 46 meters. But the reason why it can appear in your room is because it's scaled down. So it's scaled down to only 2% of each of those values, which makes it reasonably sized in order to be displayed. If you want to quickly compare how big your dice is when compared to this ship mesh, you can actually just select the ship mesh and hit Command C to copy it, and then put it in as a node inside your dice scene. So let's change again to front camera. So this is what we see when we actually open the app, and let's double click on the ship mesh to see where that ship is. And you can see that our dice is that tiny little object over there. So you remember how big the ship was. Now you can see how big the dice is when compared to that ship. So it's pretty small. And if you want, you can scale up the dice. Say if you wanted giant dice to throw on the floor in your app, then you could simply just change that scale up or down. But for me, I'm actually going to keep it at this size because it actually seems to work quite well for a dice app. Now, the other thing that I want to show you is that you might notice that the ship is a scene file, but our dice collider is a DAE file. And you can actually convert a DAE file into a .scene really easily. Just select the file and then go to Editor, Convert to SceneKit scene file format, and it will do that for you. So, dice collider.scene. So now we can go into our view controller and we can go about adding some code to bring our dice into our app. So the first thing I'm going to do is I'm going to comment out all of this code that's related to our sphere. So I'm going to comment out all of that, but I'm going to leave that line of code for the default lighting. All right, cool. So the next thing I'm going to do is I'm going to uncomment that little bit of code that we had from earlier on that rendered the plane. But we're going to edit this slightly. I'm going to delete this line and I'm going to change this from rendering the ship to our dice collider. And remember that you have to keep the capital there, otherwise it won't recognize it. All right, so there's our dice scene. And let's call it that to make it a bit more explicit, dice scene. And then we're going to create a dice node to create a 3D position to put our dice. So we're going to say let dice node equals dice scene dot root node dot child node, and we're going to use the method that's going to look for the child node that has a particular name. And to find the name, all you have to do is go into that dice collider file, select the dice node, and you can see that it has an identity attribute. And this is the name that you're looking for. So I'm just going to copy that and put it here. So we're going to look for a child node inside the root node of the dice scene that is created from this dice collider.scene file. And then we're going to set recursively as true. So what that recursively does is that it basically allows you to search through the tree and include all of the subtrees in the child node. So what does that all mean? If you have a look inside the ship scene, so you can see that ship mesh is a child node of ship and emitter is a child node of ship mesh. So if we were looking for emitter, but I happen to use the ship mesh identity, if I had recursive, then it'll include and search for that emitter child node as well. It basically just goes down into the tree and looks at all levels to find that name, ship mesh. But in our case, it's looking for something called dice inside this dice.collider scene. And even though it doesn't really need to be recursive because we know that it doesn't have any child node branches, it's just a good habit so that when you do have more complicated scenes, then your code will still work. So now that we've created our dice node, we need to give it a position. So dice node.position. And again, we're going to be using the SEN vector 3 to create this position. And in this case, I'm going to set the X as 0 in the center. The Y, I'm going to set it about the same level as the view. And then the Z, I'm going to set it slightly closer in front of me. So I'm just going to set it to minus 0.1 instead of minus 0.5, which we had. It's a little bit too far away, I think, for the dice because it's so small. And the last thing we need to do, if you remember, same as up here, we just need to tap into that scene view that we've got, select the scene that's inside the scene view, select the root node, and add our new dice node as a child node. All right, so that's almost done, but you see one error from Xcode. At the moment, you can see that dice node is an optional, and that's because it might search through your tree and find nothing with the name dice, in which case then dice node is going to equal nil. So this line is fine because we're using optional chaining to see if dice node exists, then we will set the position, but this is a little bit more problematic. We're trying to put the dice node inside our scene, but what if it's nil? Then our app will crash, right? So if you decided to just force unwrap it, then you could get into some really hairy situations. So I'm going to wrap everything inside an if let, just to be safe. So basically, if dice node is not nil and this succeeds, then we are going to set its position, and also we're going to add it as a child node. So we no longer need that optional chaining, because for us to enter in here, then dice node has to equal something. So let's give it a spin. And that's all you need to do to add a 3D model into your app using ARKit. So have a look at TurboSquid and see some of the other cool things that you can port into your app. There are thousands upon thousands of 3D models that are really, really awesome. And you can use the same technique that we used to bring in a dice into our app to bring anything else. Maybe a 3D model of a heart, or maybe you want to plant some trees, whatever it may be. Go nuts, and be sure to let me know if you create anything cool. We'd love to check it out and congratulate you. So I hope that was fun. In the next lesson, we're going to take it to the next level. So one of the things you might have noticed is that our dice at the moment is floating in midair, which is terribly unrealistic. So on the next lesson, we're going to enable plane detection. And this is something that is really cool in ARKit. It basically allows you to detect flat surfaces in order to place your objects onto those surfaces. And it's going to allow us to put our dice onto a table or onto the floor, and it'll look a lot more realistic. So all of that and more on the next lesson. I will see you there.